Alright, so today what I want to cover is Chapter 6, which is on vectors and arrays. And I'm going to start by just talking a little bit about what these things are. Basically, let's start with vector. That's the easy one to think about, I believe. A vector is like a container. And it's a container that puts things in a sequence. And it doesn't have a fixed size. It's expandable. So you can make it as big as you need it. And you put things in it. And when you create a vector to use as a container, you have to tell the system what is the type of object that you're going to store in the vector. So if you declare your vector, you say this vector is a container of integers. And you can't then put a double in there. That will be rejected. So a vector is used to contain objects of the same type. An array is also a sequence or an arrangement of objects as well, all of the same type as well. So it's similar. The main difference between a vector and an array is that when you create an array, you specify the size, and the size remains fixed from that point on. So if you want an array, you have to give it a name, call it A. So array A, and then you have to give it a size. You'll say 20. From that point on, array A will always have 20 members, 20 elements. You can't change the size. But if you create a vector V, and normally you start with a vector that has no elements in it, a vector that's empty, and then you add elements to it one after another, and the vector expands to store those elements that you put into it. In the last lecture, we looked at solving that that street and house problem. And I mentioned that our solution felt a little unnatural because we're only storing the first house and the last house. So we have a street class, and the concept of a street is that the street contains some number of houses. We don't know how many. We want the street to be general in the sense that it can represent any number of houses. So it's like a vector. A vector is something that can hold any number of things. So when we implemented the street, we didn't quite. It was not quite a satisfying implementation in the sense that we didn't store all of the houses that were part of the street. We only stored a first house and a last house. So what I'm going to do now is let's see how would we have solved this street representation problem using a vector instead of the way we solved it. So let's go back and take a look at that. I think I have that set. That's the startup project. I'm going to run that. So we give a house location here, another house location. We type in the house numbers and the number of houses on the street, and we plot those houses in a line. So let's change the representation a little bit. Instead of storing the first house and the last house, let's store all the houses. Let's create, if there's 8 houses, let's create 8 instances of the house class and store those 8 instances. So it would look something like this. So first of all, we have a header file we need to include. And it's called vector. So that brings in the definition of this, what's called a vector template class. And now instead of storing first house and last house, let's store a vector of house. We'll call it houses. That's the syntax. That's how you declare a variable, houses, and which is a vector of house. So the data type of the element that's inside the vector is placed in these angle brackets. This is the same syntax in Java and C# languages as well. Exactly the same syntax. Let's take a look now at the implementation for this street class. So the street, we can still pass in a first house and a last house, and the number of houses on the street. But this time what we're going to do is just keep those as locally scoped objects. So we only need them inside this function. And once we use them, we're going to use these to create the houses in between these two houses and store all of those houses in the vector, and then we can discard these objects. And we also don't need this. We don't need number of houses on the street because that information can be stored in the vector. So once we have a vector, we can always ask the vector, how many objects do you have in you? And so rather than maintaining that information redundantly with this variable called number of houses on street, we can just let the vector maintain that number for us. So we can take that out. All right, let's take a look. So we don't need this. So what we'll do is we can move the plot function gives us a suggestion of what we need to do. So we're going to have a loop. We're going to have, number of houses on the street. That's what's getting passed in here. So we're going to need a loop that's we're going to need to perform this many insertions into our vector. So number of houses on the street, that's a number. We're going to have to insert that many houses into our vector. Now the first house and last house are being passed to us. Actually, we don't need this, they're redundant. We don't need that because it's it'll look a lot like this plot function in here. Let's take a look at that. Actually, just this whole thing right here looks a lot like the plot function. We can change this. This is the number of houses to create. See, we have two houses already. We're going to insert this house into the first position in the vector. Then we'll insert the houses between the first and the last. And then finally we'll insert the last house. This is, I'll just change this instead of arg. We don't need that. Stank that build. Okay, now that resolves. And let's change these as well. So we have a vector called houses. Now how do we insert an element in this vector? At this point in time, the vector is empty. So we want to insert the first house. Well, if you're in Visual Studio, it's a lot easier. You can get a list of the functions that you can call. But it's not that easy because the function we want is called pushback. So we want to push onto the back of the vector a new object. So we insert the first house. And then here, when we create, this is where we created the house for the purpose of plotting it here. We did this last time. We went into this loop that ran, if we want 8 houses on the street, then this number that gets passed into us is 8. That means we have it, and we have a first house and a last house already. So that means we need to create 6 houses. So that's the number of houses to create is the number of houses on the street minus the first and the last 2. So this loop is going to run this many times. But instead of plotting the house, we want to add the house to the vector. So instead of plotting the house, let's add the house to the vector. Finally, after we add those houses, let's add the last house. So it looked a lot like the plot function. We're going to need to change the plot function. The plot function will look a lot different. So in fact, it'll look so much different that we're not even going to use that. What we want to do is iterate through the vector. So there's a number of ways to do that. Let me see how the book shows it. I'll be consistent with the book. Do they use iterators in the book? Does anyone know? Are they advocating iterators, or do they just use the for loop? Anybody? All right, I see a for loop there on the first example. So what we want to do is we'll have an index I, and we're going to range through the vector. Now let's take that example. We have 8 houses. That means there's 8 things in the vector. So we have the house in the first position, the house in the second position, like that, all the way up to the house in the 8th position. Now each position you can access through an index. But the indexes start at 0. So the first position is index 0. So we set I to 0. That's the starting state of our index. And we want I to range from 0 to 7. In other words, we want I, the index, to be less than, strictly less than, the size of the vector. In the example that we're talking about with 8 elements in the vector. So houses.size is 8. Well, we want I to range from 0 to 7. If we let I range from 0 to 8, we'll get 9 houses. So that's an off by 1 problem, which is very common in computing. And the other thing to keep in mind in computing, normally, unlike humans, computers start counting from 0. So if you gave a computer the problem of count the number of students in the class, the computer would go, oh, 0, 1, 2, like that, see? But a human would start with 1, 2. So but the computer almost always starts with 0. And there's a reason for that. Just internally, if you dig down inside and look at the lowest level of the operating system and the machine instructions, you'll see that 0 is a very, very convenient and natural starting point when you count. And so the languages that have evolved out of the invention and development of computers have evolved from that point forward, and that's why we start counting at 0. Although there are situations where you start counting at 1, but those would be more exceptions than the rule. So here's a loop that has an index, integer I, range through all of the elements in the vector, all the indices that are valid in the vector. So what we want to do is for each house in the vector, we want to call its plot function. Whoops, that's houses. The vector is called houses because it has more than one. This is how we do it. So this is the identifier, or the variable name, that names the container, that names the vector, the thing that contains the items. And to specify one item out of the sequence of items in the vector, we use this syntax. We use a square bracket followed by the index number with a closing square bracket. So this is the ith, or the item at index I in the house's vector. So give us this, and then once you give us that, then invoke its plot function. We could have done it like this. Here's an equivalent expression. These two statements do the same thing as the second statement. We can pull out a house at index I, and then we invoke its plot function. So these mean the same thing. I'll just leave that in there. I like the one-line version better. So there we have done it. We've made an adjustment. Look at our new street only has one argument, or one data member now. This builds. There's a warning. Let's fix the warning. Signed, unsigned mismatch. Line 31. See, it's expecting this this size here returns size unsigned int. I don't see it listed here, but this is in fact an unsigned int. So if I is an unsigned int, then this I is now an unsigned int. Now it has the same data type as the number returned by size. So now the compiler is not going to warn us, because an unsigned int and a signed int are two different data types. It doesn't result in an error, but it gives us a warning. So let's try this again. We'll do 8 houses. There it is. So that's just shows you how to use vectors to reformulate the solution to the problem we worked on last time. Is there any question about vectors or how to use them at this point?